Hello everyone. Let's start with the LTC MPL unit test 2 solution. Question number 1. The maximum number of electrons possible for n is equal to 4 and L is equal to 2. Okay. So we are talking about fourth shell and L is equal to 2 signifies D subshell. Okay. Now how many electrons are present in D subshell? Number of orbitals in a shell is 12 plus 1 and the number of electrons will be 2 into 12 plus 1. Okay. So that is how you can calculate the number of electrons for L is equal to 2. So it comes out to be 10. That is the correct answer. In hydrogen atom, the radial distance between successive orbits is maximum. Okay. Now, what is the formula for the radius of orbit? It's a naught n square by z, right? Because atom is fixed hydrogen, so I can say radius will be proportional to the n square. Okay. Now, the radial distance is maximum. Okay. So we are talking about the maximum value of this, right? Radial distance, that means the radius of outer orbit will be n2 square proportional to n2 square and the radius of inner orbit will be proportional to n1 square. So we are practically looking at the value of n2 square minus n1 square. Now for this it will be 2 square minus 1 square, which will be 3, right? For this it will be 5 square and 4 square, which will be 9, right? So that is how you can do for all of them. You'll find out that the maximum difference is for this pair. Okay. Next question. De Broglie wavelength of a particle of mass 10 to the minus 27 kilogram moving with a velocity this is this much. Okay. So what is the formula for de Broglie wavelength? It's h by mv. Wavelength is equal to Planck's constant divided by the linear momentum. So let us substitute the given values. It is this. The mass of the particle is 10 to the minus 27 kilogram multiplied by velocity is 10 to the power 5. So you can adjust the values and you can find out that the power will come out to be 10 to the minus 12. Okay. Next question. Number of radial nodes in 4D orbital. Now what is the formula for radial nodes? It's n minus L minus 1. Okay. So for 4D orbital, how many radial nodes? 4, the principal quantum number, minus L value for D subshell is 2, minus 1. So this is 4 minus 3, that is 1. Okay. Now you can find out for all of them. For this it will be 3 minus 0 minus 1, which will be 2. For this it will be 5 minus 1 minus 1, which will be 3, and for this principal quantum number minus 1 minus 1, so it will be 1. Okay, so for this will be 4 minus 3 minus 1, that is 0. Is that clear? So this is a correct answer. Wavelength of the second line of Balmer series. Okay, when do we get in a line in Balmer series? When the electron drops to n is equal to 2. Okay, line 1 Balmer, Pascal bracket front, like that. So for Balmer series, the electron drops in second orbit. It has to start at least from 3. So the first line is from 3 to 2. The second line is from 4 to 2. Okay, so we are looking at this line, wavelength of second line of Balmer series. So we are talking about 4 to 2 transition. Okay. The energy difference will be Rydberg constant and 1 upon 2 square minus 1 upon 4 square. So if you will work it out, you will find that it is 16 and 4 minus 1, 3. Okay. Now because energy depends inversely on the wavelength, so this will be 16 divided by 3 times the Rydberg constant. Okay. Velocity of X-ray is equal to velocity of UV rays. Yes, the speed of all electromagnetic radiation is equal in vacuum. It is equal to the 3 lakh kilometer per second. A specific charge of electron is less than the specific charge of proton. So what is a specific charge? It is equal to charge divided by mass, right? Now we know that the magnitude of charge is equal on an electron and a proton. So we are looking at the denominator. Now the mass of electron is less. So because the mass of electron is less, its specific charge will be more. So actually this statement is incorrect. So the correct answer is second, right? You have to identify the correct statement. Both 1s and 2s orbitals have different number of nodal planes. No. Nodal planes is equal to the angular nodes, and which is equal to L. So L value is 0 for s orbital. So both of them have 0 nodal planes. That is equal, right? Chromium atom shows anomalous configuration. Yes. Instead of 3d4 4s2, chromium atom exhibits 3d5 4s1 configuration because half filled subshells are more stable. Okay. So this is the correct statement. In hydrogen atom, energy of orbital depends on the value of principal quantum number and azimuthal quantum number. No. In fact, for one electron species, the energy of electron depends on the first quantum number only, that is n. So this statement is incorrect. This was incorrect. Bohr's theory cannot explain Stark effect. Yes, if we apply electric field, then the spectral lines are split, right? Why does it happen? Bohr's theory cannot explain that. So the correct answer will be B and D. Okay. Next question. The product of uncertainty of velocity and position is minimum. So we are applying Heisenberg uncertainty principle here, which says that the product of position, error in position and error in momentum, it has to be greater than or equal to h upon 4 pi. Because we are looking at the uncertainty in velocity, so I can write the error in momentum as m delta v. Correct, guys? And this I can take for the numerical purpose h upon 4 pi, and the product of velocity error and the position error. So this will be delta x into delta v. So it is h upon 4 pi m. Now we want this product to be minimum, so mass of the particle should be maximum, alright, because it depends inversely on the mass. So the mass should be maximum, yes, so this becomes the correct answer because it is the heaviest particle. Minimum number of atoms are present in, it's very simple, you multiply the moles by the atomicity, okay. So SO3 is 0.4 mole multiplied by how many atoms are there in SO3? 4. So this gives us 1.6 mole of atoms. Likewise, you do all for all of them. So this will come out to be minimum for methane. So it's 1 and 4 and a 5. It's basically 1 mole. Okay. So it's 1.5 mole. You can calculate that. It's easy. And this is 1.4 mole. Okay. So this is our correct answer. Weight of 40% pure limestone, which gives carbon dioxide. So what is the equation? Calcium carbonate decomposes to give calcium oxide and CO2, right? Limestone is calcium carbonate. Now, if you look at the stoichiometric relation, 1 mole of calcium carbonate will give me 1 mole of carbon dioxide, okay? Right? Now, the molar masses are 100 gram for calcium carbonate and 44 gram for carbon dioxide, okay? So, if I need 4.4 gram of carbon dioxide, that is 0.1 mole. So, the mass of pure limestone that I would be needing is 10 gram, right? But limestone is 40% pure. It is not 100% pure. So, what do I do? Let us consider that we need x gram of limestone, okay? So, 40% of x should equal 10 gram, right? I will take some amount of limestone, 40% of which should be equal to the 10 gram of limestone which I actually need, okay? So this is equal to 40x by 100 is equal to 10. You can work it out, x will come out to be 25 gram, okay? Next question. Nitric oxide, sorry, is NO plus O2. It reacts to give NO2, right? So if you balance this equation, you will get 2NO plus O2 gives 2NO2, right? If V liters of nitric oxide reacts with excess of oxygen to produce 5 liters of nitrogen dioxide. Now, if you look at the stoichiometry of this reaction, you will find that for 2 moles of NO, there is 2 moles of NO2. So the ratio is 1:1. So if you have obtained 5 liter of nitrogen dioxide, you must have taken 5 liter of nitric oxide as well. So this is the correct answer. An organic compound contains this hydrogen, this carbon and remaining oxygen. Molecular formula is, so you will have to begin by calculating the empirical formula, which is pretty easy. You just have to find out the ratio of their moles, right? So moles is mass divided by molar mass, and I can take the mass of hydrogen as 2.22% by its molar mass 1, the molar mass of hydrogen atom, okay? For carbon, it is 26.67 divided by 12, and remaining 100 minus 26.67 plus 2.22 divided by 16. So you can find out, you will get the empirical formula, and then you know that molecular formula is always an integral multiple of the empirical formula, right? So in that case, I'm telling you, you will find CHO2 to be the empirical formula. So this has to be the molecular formula, right? This could be one of the molecular formula. Next question, oxidation states of iron in Fe3O4. You should remember that it's a mixed oxide and it actually consists of this, right? FeO and Fe2O3. So if you look at the oxidation states of iron, then you will find out that this iron is in +2 oxidation state and these two iron atoms are in +3 oxidation state. So this becomes our correct answer. Here potassium permanganate is reacting with reducing agent. The gram equivalent weight of the KMnO4 is 31.6 gram. Okay, so you should know that the molecular mass is 158, right? And its equivalent weight is 31.6. And you should also know that the relation between equivalent weight and molar mass is this, right? Equivalent weight is molar mass divided by n factor. So you can find out n factor here, which will come out to be molar mass 158 divided by equivalent weight, which is 31.6. Is that clear? So this will come out to be 5. Then you should know the reaction is carried out in acidic medium, because it is an acidic medium where the n factor of potassium per magnet is 5. Okay, I can show you the equation here as well. MnO4 minus in plus 7 state, it gains 5 electrons and it gives us Mn2 plus. Okay, so the n factor is 5. Remaining, you can balance this equation. Here we have 4 oxygen, so you will add 4H2O this side and 8H plus ion this side. So this is the half reaction of KMnO4 in acidic media. Again, you have to balance this equation. Plus 7 is the oxidation state of permagnet, and here it is plus 2, and iron is going from plus 2 to plus 3. So basically you can see that loss is of 1 electron, iron from plus 2 to plus 3, and gain is of 5 electrons, right? Because MnO4 is going in permagnet, manganese atom is going from plus 7 to plus 2. So to conserve the electron, we will multiply this by 5. So Y will be 5, likewise B will be 5. Okay, so and then permagnet is only 1, right? Because it already is gaining 5 electrons. So X is 1, likewise A should be 1. So here we get our answer. But anyways, there are 4 oxygen atoms, so you need 4 oxygen atom here, right? And 4 into 2, 8 H plus here. Is that clear? That is the correct answer. You have to tell the element which is in the highest oxidation state. So you can find that out. Hydrogen is plus 1, chlorine is minus 1. So this will come out to be how much? It will come out to be plus 2, right? This will come out to be minus 3, this will come out to be minus 2, and this will come out to be plus 3. So this will be our answer, right? Fluorine shows fixed oxidation state of minus 1 in all its compounds. Element E shows highest oxidation state. So you should know that for group 16 the highest oxidation state is plus 6, because they have 6 valence electrons. For group 7 it is plus 7. For group 17 it is again plus 7 halogens, and for group 18 it is plus 8, right? The very well-known element is xenon. It shows up to plus 8 oxidation state in compounds like XeO4, right? So it is showing plus 8. So that is the correct answer. Is that clear, guys? Next question. The work function of the metal is 3.9 electron volt, and you have to find out the kinetic energy when the wavelength of the incident photon is 200 nanometer. So first let us find out the energy of the incident photon in terms of electron volt. So energy as Planck's quantum here is hc by lambda. So let us substitute the values. The value of hc is approximately I can say it's 2 into 10 to the minus 25. You can remember this value. It will be handy. The wavelength is 200 nanometers, which is basically 2 into 10 to minus 7 meter. Okay, so this will come out to be 10 to minus 18 joule. Is that clear, guys? Now you have to convert it in electron volt. So let's divide it by that. 1.6 into 10 to minus 19 joule per electron volt. That is the value you should remember. It is the value of 1 electron volt. Then this will come out to be approximately, this is 10 by 1.6, approximately 6.2 something. Okay. So now you use the Einstein's photoelectric equation that the maximum kinetic energy is equal to the energy of the incident photon, which is 6.2, minus the work function of metal, which is 3.9. So this will come out to be approximately 2.3 electron volt. So that is our correct answer. Clear, guys? Next question. Sodium carbonate decomposes on heating? No. Sodium group 1 carbonates are highly stable towards heat. They do not decompose easily. In fact, they melt before decomposing. So statement 1 is incorrect. Lithium hydrogen carbonate cannot be obtained in the solid form. Yes, in group 1 elements, all the bicarbonates are stable in solid form except lithium, because lithium is highly polarizing cation. So this becomes a correct answer. The first group element with least melting point is cesium, because down the group metallic bonding becomes weaker and the attractive forces will also become weak, so melting point will decrease, right? So heaviest element will have the lowest melting point. Thermal stability of barium carbonate is greater than the beryllium carbonate. Yes, it is correct, because down the group the stability of carbonates increases. Solubility of barium sulfate is less than the solubility of beryllium sulfate. Again, this makes an exception actually, because beryllium has a very high hydration enthalpy. So despite high lattice enthalpy, beryllium sulfate is soluble in water. So both the statements are correct. You have to choose which metal cannot undergo this reaction. So you should know that lithium shows anomalous behavior, so lithium cannot be this metal. Okay, group 1 group 1 elements react like that. Okay, group 2 elements, when their nitrates are heated, they actually give oxide and not nitrites. Okay, so these three, that is the correct answer. At 1200 Kelvin, beryllium chloride exists as a monomer, right? Its hybridization is sp and it exists as monomer, right? So this becomes the correct answer. This is in the solid phase, where the hybridization of beryllium is sp3, and this is in the vapor phase below 1200 Kelvin, where the hybridization of beryllium is sp2. The process is least feasible. Obviously, it will be for thallium because it shows inert pair effect. Its +3 state is highly unstable. Okay, you have to you have to tell the correct bond order. Okay, so for lithium, how many electrons are there? 6, right? So this can be done using MOT. I can write the electronic configuration for you: sigma 1s2, sigma star 1s2, and sigma 2s2. So the bond order will be half number of bonding electrons, which are in non-star orbitals, right? The orbitals in which we don't put star, right? So this is 4 electrons, and anti-bonding are those which have a star. So this will be 2. So the bond order will be 1. Is that clear? For Li2 plus, guys, I will remove 1 electron from this orbital. So I have one less bonding electron. So this will be half. And for Li2 minus, I will put one more electron in sigma star 2s1, right? So the bond order for lithium will be, bonding electron will be same, but I have one extra anti-bonding electron. So this again is equal to 0.5. So the bond order of lithium is maximum, and the bond order of lithium cation and lithium anion both are equal. Is that clear? Next question: which of the following has pyramidal shape? So you'll have to actually find out the shapes. You can do that via hybridization or like, so NO3 minus, it's also just put nitrogen here. Okay, just put nitrogen here. There is a coordinate covalent bond and it's nitrate ion. But sulfide ion is pyramidal because the hybridization of sulfur is sp3, right? So there is a lone pair, there is a doubly bonded oxygen, there is a singly bonded oxygen, there is another. This is carbocation. Carbocations are planar. If you find out its steric numbers, it will come out to be 3. So basically, carbocations are planar. Vacant p orbital. Okay, so this is the correct answer. The molecule in which the central atom has maximum number of lone pairs of electrons. So you'll have to find out the steric number. Bromine has 5 electrons, 7 electrons in its valence shell. 5 electrons are distributed, 2 electrons are remaining. So this is one lone pair. Xenon has 8 electrons, 4 electrons it shares with 4 fluorine atoms. 4 electrons are left unshared, so 2 lone pairs. XeF2, xenon has to share only 2 electrons. It gets to keep 6 electrons, that is 3 lone pairs. And in ClF3, it has 7 electrons. It shares 3 electrons with fluorine atoms. It gets to keep 4 electrons, which is basically 2 lone pairs. So XeF2 has maximum number of lone pair on the central atom. Which of the following is a diamagnetic species? B2 is paramagnetic because if you write the electronic configuration of molecular orbitals, you will find that there are 2 unpaired electrons in pi bonding orbitals, right? So it has a bond order 1 anyways, and it is not diamagnetic, it's paramagnetic. Oxygen is paramagnetic, right? Because it contains 2 unpaired electrons, pi star 2px1 and pi star 2py1. So it does have a bond order of 2, but it is not diamagnetic, it's paramagnetic. For C2 molecule, yes, if you write the electronic configuration, you'll find out that it looks like this, right? So it has 4 electrons. It has 4 electrons, so it has a bond order of 2 and it is diamagnetic. So that is the answer. For this beryllium molecule, the bond order is 0. It doesn't exist. Number of planar hydrogen atoms in diborane molecule. Okay, guys, so this is a special molecule because it has 4 normal covalent bonds, which we also call 2 center 2 electron bonds, and the 2 hydrogen atoms are special because they form 3 center 2 electron bonds. Okay, guys, so basically you will find that this I can take as the molecular plane, So there are 4 hydrogen atoms in the molecular plane and 2 boron atoms. So the answer is 4 because we are only talking about the number of hydrogen atoms here which are in molecular plane. Okay. Lewis theory cannot explain the shape of the molecule, correct, because it only gives the distribution of valence electrons, right? The stability of hydrogen molecule is because of its duplet. Hydrogen cannot have 8 electrons in its valence shell, it only has first shell. So statement 1 is correct, but second is incorrect. Which of the following species cannot exist? The one which has a bond order of 0. So for helium, you will find out that its configuration is sigma 1s2, sigma star 1s2. Bond order will be half of number of bonding electrons minus number of anti-bonding electrons. Basically, there is no bond between two helium atoms, so its bond order is 0. It cannot exist. Next question is bond order in O2 minus is X. So you can find out the bond order, right? You write the molecular configuration. So for example, for O2 minus is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, then pi 2px2, and pi 2py2, and then we have pi star orbitals. Okay, pi star 2px, pi star 2py. Normally what happens if it is oxygen molecule, then we have one electron each, right? One electron each, pi star 2px and pi star 2py. In case of O2 minus, you will have one more electron, so it will be 2 1. Is that clear? So that is how you can find out bond order. So in O2 minus it will be 1.5, and O2 minus it will be 1. So the sum of the bond orders is 2.5. Clear? Species having minimum NN bond order is, obviously you can find out again, bond order in N2 is 3. If you remove one electron, it will be 2.5, and if you add one electron, it will also be 2.5. Okay? If you remove two electron, it will be 2, right? So it is having minimum bond order. Hybridization of the central atom in AB4E. So basically guys, there are 4 bond pairs, 1 lone pair. Now if the central atom has 5 electron pairs in total, so obviously we need 5 hybrid orbitals. Okay, so the hybridization is sp3d, trigonal bipyramidal. The bond angle is highest in, you'll have to draw it, the shape. In SO2, hybridization is sp2 and bond angle is approximately 120 degrees. Whereas BeCl2, when we say, we talk about the individual units. So the bond angle is 180, right? You can draw their shape. In BF3, it is 120 degree. It's a symmetrical molecule. And water, although it's tetrahedral, but because of the lone pair, and lone pair bond pair repulsions, the bond angle reduces to 104.5 degrees. So the correct answer becomes BeCl2. Clear, guys? Most polar bond, obviously its polarity is proportional to electronegativity difference, so the maximum electronegativity difference is between carbon and fluorine. 1 dB is equal to, it's factual, 10 to minus 18 ESU centimeter, it's CGS units, guys. ESU stands for electrostatic unit. Polar molecule among the following in which the resultant of the individual bond dipoles is not 0. So BCl3 is symmetrical molecule, bond dipoles will cancel out. SF6 is also a regular octahedron. Ammonia, the bond dipole will cancel out, right? They will have the net dipole moment as 0. Methane is also a regular tetrahedral molecule. Actually, in ammonia, there are 3 bond pairs and 1 lone pair. So yes, it is unsymmetrical. Its bond dipoles all point in the same direction. That is, they add up actually. So ammonia is a highly polar molecule. Okay. So that is the correct answer. Which of the following contains both ionic and covalent bond? Obviously, there is an ionic bond between potassium and oxygen, and a covalent bond between oxygen and hydrogen, because between two non-metals the bond is covalent. Okay, here it is covalent bond because both are non-metals. Here it is ionic bond because one is metal and another is non-metal, and both carbon and oxygen are non-metal, so there is a covalent bond only. This becomes the correct answer. Pyrrole, phenol, THF, tropon. You can draw their structures. Okay, then you'll find out that this is the correct answer. Okay, pyrrole is this. Okay, then phenol, you guys know, tetrahydrofuran is basically you hydrogenate the molecule, and tropone is a 7-membered ring with a keto group, right? So you can find out which is the correct answer. Correct structure for 5,5 dimethyl hex 2 in it will be H2. Then you can find out that it's we give double bond the priority. Okay, you should know that double bond gets priority over the substituents. So 1, 2, 3, 4, 5, 6. So 5,5 dimethyl hex 2 in, right? This becomes a correct answer. A bond formed between two electronegative atoms is a covalent bond. That is two non-metals basically. Which of the following represents the correct structure? Iso group is, guys, this is iso group. Okay, this is iso group. So basically isobutyl. So we have 4 carbon atoms. This is n-butyl. This becomes the correct answer, by the way. This is n-butyl. This is tert-butyl. This is sec-butyl. Okay. Intermolecular hydrogen bonding is not observed in water gas, right? In steam, we don't observe intermolecular hydrogen bonding. In other thick cases, we do. All of the following molecules are involved in intramolecular hydrogen bonding except para-hydroxybenzaldehyde, because the distance between the two substituents is very large. Hydrogen bonding cannot occur. Okay, so para-hydroxy, so one is OH and other is this aldehyde. So the distance is large. There will be intermolecular hydrogen bonding, right? In all these cases, the groups are ortho to each other, so they are near. They can engage in hydrogen bonding. So this is the correct answer. All of the following compounds have same or nearly same molecular weight. The compound with the highest boiling point. Now, boiling point is proportional to the attractive forces. Ethanol is an aldehyde. It has dipole-dipole forces, which are definitely stronger than dispersion forces and dipole-induced dipole forces. But ethanol has hydrogen bonding, right? Ethanol has a hydrogen bonding, which is stronger than all the Van der Waals forces. So basically, this becomes a correct answer. Okay. Propane is alkane, only dispersion forces, the weakest one, and methoxymethane is an ether. It also shows dipole-dipole forces, which are weaker than hydrogen bonding. Ratio of hybrid orbitals to pure orbitals in ethine molecule. Okay, so you should look at ethine. Then per carbon, you will see the bonding, right? So we will talk only about the valence shell. So we have 2s, we have 2px, we have 2py, and we have 2pz. For carbon, and for hydrogen, we have 1s orbital. Okay. Now, in because ethine is linear, we need 2p orbitals for pi bond formation. So we'll keep them unhybridized, right? And we will hybridize 2 orbitals. So per carbon 2 orbitals. So how many hybrid orbitals in total? 2, right? 2s 2px for this, 2s 2px for this, right? So there are 4 hybrid orbitals, and unhybridized orbitals are 2 per carbon atom and 1 hydrogen atom. Okay, so 3 into 2 is 6. So basically the answer will be 2:3. Correct, guys? Number of primary hydrogen atoms in 2,2,4 trimethyl pentane. So basically, what is 2,2,4 trimethyl pentane? It's this. You can draw its structure. Am I right? Okay, so 1, 2, 3, 4, 5, 2,2,4 trimethyl pentane. So we are basically looking at primary hydrogen atoms. So all these are primary carbons. The hydrogens joined to them will be primary hydrogens. So the answer is 50. Okay. Molecular weight of an organic compound is 100, and the homologues differ by a CH2 unit. Okay, and the molecular mass of CH2 unit is 14. So you have to either add or subtract 14. So you will see that this would be right. If you subtract 2 CH2 units from 100, that is, if you subtract 28, so you will end up getting 72. Okay. Which of the following organic compound does not contain a secondary suffix? So alkyl halide does not contain a secondary suffix because as per the IUPAC nomenclature, it is called haloalkane. So it only has a primary suffix, that is ane, whereas alcohols are called alkanol. Okay, so there is a primary suffix ane and there is a secondary suffix ol. Aldehyde is called alkanal. So the secondary suffix is L, and carboxylic acids are called alkanoic acid. Okay. So the secondary suffix here is oic acid. Is that clear, guys? So I hope you understood. Your doubts are cleared. Thank you.